Hey everyone, today we're going to talk about estimation in physics and just in life in general. We're going to use some of the scientific notation skills that we've been talking about lately here in class. A classic question to ask in this situation is kind of a fanciful one, which is how many piano tuners are in New York City? Now, obviously, you could just look this up on the internet or something like that. The answer isn't really what we care about. We want to think about how we could estimate that value in a sensible way. So to answer that, we really want to think about how many people are in New York City. And we know, we'll just use the number 8 million. That's 8 times 10 to the 6th people per New York City. For every one New York City, you will find 8 million people. We can also ask ourselves, how many pianos are there per person? Now, we could argue about this and perhaps not really come to a sensible answer, but I'm going to just go out on a limb and say that for every 300 people, there's one piano. So that's 1 over 300, and I'll approximate that to be 3 times 10 to the negative 3 pianos per person. So if we look at that, you can multiply that out, and you're going to get 24 times 10 to the third, that's just 8 times 3, times 10 to the 6th times 10 to the negative third. And if we look at the units, we get what's perhaps a little bit more interesting. Looking at the units, we see that people and person cancel out, leaving us only pianos per New York City. 24,000 pianos for New York City. Does that feel right? I don't know. That seems like not a crazy number. It's a big city. There might be 24,000 pianos here. But of course, we want to know how many tuners there are, so we're not really done yet. So I've changed the way I express the number of pianos from 24 times 10 to the third to 2.4 times 10 to the fourth pianos per New York City. But to know how many tunings there are, we really need to guess how many annual tunings there are per piano. And I'm going to just guess, having never owned a piano, that if you get it tuned every 2 years, that's about 0.05 annual tunings per piano. And we can, once again, look at the units, and the multiplication is rather simple this time. It is 1.2 times 10 to the 4 annual tunings per New York City. So our estimations have led us to about 12,000, or 1.2 times 10 to the 4, annual tunings in New York City. But to know how many tuners that is, we need to figure out how many tuners for an annual tuning. Meaning, how much of a year does a tuner spend tuning a piano? I'm going to guess tuning a piano takes about all day. I don't really know. And let's say that there's 250 days in a year that they work. So that would mean 1.2 times 10 to the 4 annual tunings per New York City times 4 times 10 to the negative 3 tuners per annual tuning. And once again, we can look at the units on that, and we see that all that's left is tuners per New York City, which is, of course, exactly what we were hoping to find. So let's see how this all works out. That's 1.2 times 4, or 4.8, times 10 to the 4th times 10 to the negative 3rd, or 10 to the 1 tuners per New York City. That looks like about 48. What do you think? Does that seem like a decent number? Well, of course, these are all great estimates besides the number of people in New York City. We really have very little leg to stand on with any of these numbers, but we have something like 50, or on the scale of about 100-ish tuners. I think if you look that up, you'd see that that's not a crazy number at all. It's pretty good. So if we look at all of this together, the people in the city times the pianos per person times the tunings per piano times the tuners per tuning. So if we look at all these multiplied together at once, we can see first on this top line, I'm just going to cancel all of my units that cancel. People and persons, essentially the same unit. Pianos and piano. Annual tunings and annual tunings. All of that goes away, leaving only tuners per New York City. So I already know that that's my units at the end of this operation. Now I can look at all of the exponent and coefficient portions, and we see that I've got 8 times 3 times 1/2 times 4. Well, I can do that in my head, right? 8 times 3 is 24. 1/2 times 4 is 2. 24 times 2 is 48, but we knew that already. And then we can do the exponent part. That's 10 to the 6th, 10 to the negative 3rd, and 10 to the negative 3rd. That is all 10 to the 0. And we already knew that's tuners per New York City. And voila, we are done. A very nice, concise way of handling numbers. Definitely advise you try to use it rather than reaching for your calculator every time. If you break out the coefficients and the powers of 10 and deal with those individually, it works rather nicely. Thanks.